Hello everyone, welcome back. So the next type for loci in 3 dimension is the locus of points from a given line with the distance x. So how are we going to construct that? Okay, so first, given that there's a line, point A and point B, and we draw a line A, B. Okay, so when we construct or draw locus of point in 3 dimension from a given line, the concept is actually similar with locus of point equidistant from a line in 2 dimension. So in 2 dimension, usually when there is a line here, we use a compass and then we mark this arc top and then we mark arc bottom. As A is the center, next we repeat the same. With B as the center, we draw arc top and then arc bottom. So when there's two arcs here, we usually connect them together with a straight line as well as the bottom arcs. So the distance is from line AB to the top, and bottom is actually parallel line with a distance x. So that is what we're going to construct in 2 dimension. However, in 3 dimension, as usual, we have to consider the additional axis which is pointed out of the paper. So in this case, we are going to draw we're going to draw a full circle point. Start from point A as the center with the radius of 2 centimeter or x centimeter. So A as the center, and we draw a circle, and then we repeat it the same and as B as the center. Okay, so then we connect the two circles with a line. We connect the top one, and then we connect the bottom one. Okay, why do I ask you to draw a full circle in this case? Why? Because we consider the axis that is pointed out of the paper. So the locus of point can be out of the paper, or the front or the back of the paper. Okay, so if you look at the figure, it will show this 3D figure as a cylinder, and with the distance or a radius of x centimeter. Okay, so we can say that locus of a points at given distance x, or 2 centimeter in this case, from a fixed line, which is line AB, is a cylinder with the radius x from the line AB. Okay, so basically the locus of point from the top to here must be x, from the x-axis to the y-axis must be x centimeter also. So let me explain it to you in a 3D figure, real 3D figure. Okay, so let me explain to you in a real 3D figure. Okay, so as I mentioned earlier, we have z-axis, y-axis, and actually x-axis out of the paper. So let's just recap back if we are drawing this in a 2D way. So we have a line, and then we're going to draw arcs, and then we just connect the line and it will become a parallel line. So if we involve a 3D, if we do a 3D locus or loci, okay, actually involve the x-axis. So we have x-axis here, which is outside of the paper. If you look at here, zoom in. So we have a line from a line, and then the distance x is actually from the center. Okay, look at here. So from the center to the locus, the point here must be x centimeter or x distance. The same with point from point A to the top, from here to here to here to here. So if you draw all along the points, it will show a figure, a 3D figure, which is a cylinder. Okay, so if I give more opaque, and then you'll see this, a cylinder, and then okay, with the distance from A to the locus of point will be x centimeter. So this is how we draw a locus of points from a given line with a distance x. Is a cylinder with the radius of x from center to the points from the line A, B. Okay.